From IMSCAD. Now, very briefly, today's webinar, Understanding XenServer 6.2 and Nvidia Grid VGPU technology. Really briefly, a little bit of housekeeping for you all. Everybody's on mute today. We do these regular webinars. We try and keep them fairly short. This is a 30-minute webinar, so we're going to be quite punchy today and keep to the timescales. What that does mean is I won't be taking questions currently. The reason is that we basically have don't really have enough time to do a Q&A at the end. There's quite a lot to cover in today's webinar, so we're just sort of going to run through things. What I can tell you is this webinar will be recorded. The recording will be available on our YouTube. You can find the link on our website. All of those details will be available for you on the last slide. But this will be recorded and made available. There's a series of webinars that we run quite regularly, little 30-minute slots on all sorts of technology relating to CAD virtualization. So there's a lot on there. You should check it out, have a look at the website and have a look at that YouTube link with all of the webinar recordings we've got on there. But today, as I say, we're not going to take questions, but we're going to run through things fairly quickly. What we're going to do, we're going to give you a basic introduction, XenServer with Nvidia Grid VGPU technology, enabling GPU solutions, the only ones on the market really that really give 3D professional graphic workloads, full VDI deployment. That's what we're going to touch upon today. So I'm going to give you an introduction to IMSCAD. We're then going to talk about virtualization, just an overview talking about the characteristics of virtualization for CAD users. We're then going to talk briefly about Citrix, XenApp, XenServer, XenDesktop, the new VGX hypervisor that was developed with Nvidia. We'll move on to Nvidia and talk about the grid products and the VGPU technology. I'm going to go into a little bit of technical detail then. There isn't a lot of time today. Frankly, we could have hours of webinars talking about VGPU and the various ins and outs. What I am going to do is briefly explain VGPU in terms of the profiles and a little bit about the technology that makes it work. And then we're going to touch upon, as a summary, just the impact of this on the market, what this actually means for virtualization for CAD users. So without further ado, we're going to go ahead. IMSCAD, why are you on a webinar listening to us? Where do we fit in? Well, as a company, we basically are virtualization specialists. We've got data centers, 2 in London, 2 in New York, 1 in Zurich. Now, we were originally brought into the CAD market by Autodesk. We were invited to come on side with Autodesk when they released the first of their design products, which was Citrix Ready, which was Map 3D. Now, we were brought in because of our virtualization skills and asked to assist them and became an Autodesk reseller to help them take this to market and help them deploy that product. To be fair, we weren't very good as an Autodesk reseller. I think our skills were in virtualization. But what we realized fairly quickly was that there was a big gaping gap in knowledge between the virtualization companies and the application vendors. So we set about convincing Autodesk that they needed to run some pilots on their AutoCAD and Revit ranges. And we were heavily involved and instrumental in those pilots, doing those in a number of international sites. And that was all of the CAD and Revit ranges of products. So we helped them get those products into the Citrix Ready stage, where they were launched ready for Citrix. That was in the 2012 editions. And we've really continued working very closely with Autodesk in assisting them in getting their products certified for use on the Citrix platform. That has continued on to include nowadays, obviously, the suites, which we see ready for Citrix. We did the testing and certification for those. We continue testing with those. Now, I think the point I need to make here is that while we started this whole process with Autodesk, and that was what brought us to this niche sort of market, as it were, bringing our virtualization skills, but equally getting an understanding of the applications, which is very necessary in making CAD applications work in a virtual environment. But while we started with Autodesk, we were very soon introduced to a number of other applications, as we found most design users use a raft of applications from a variety of different vendors. So we're not vendor specific. We have skills in a variety of CAD and design applications, and obviously the various tools and add-ons that all designers use in their day-to-day life. So we've carried on testing products from different vendors, different tools, different add-ons, as I say, and we continued our testing with Citrix. Obviously with Autodesk, with their products, we work very closely and do testing for Nvidia on their grid products, certainly, and especially with those in terms of scalability. We've done testing for Dell and Hewlett-Packard. We work very closely with the hardware vendors and a whole host of other third-party application vendors, add-ons, plugins, tools, various things that have come to pass for design users on the way. So that's really where IMSCAD fit in, and our sort of skill sets, which is why we're talking to you today. The only other point I will make is we are the global leaders. We have deployed more CAD users on virtual environments than anybody else. We have thousands of users out there that we currently support through our help desk. So that's really IMSCAD. What we're going to talk about now very briefly is virtualization. And I just want to do this so that we can just be clear on the characteristics of a standard virtualization deployment. What does virtualization actually mean? We hear a lot spoken about clouds and different things. Where does it all really fit in, and what does it actually mean for the users and certainly for IT management? Well, in essence, virtualization is all about centralizing everything and then virtualizing it. So all of the processing, all of the data, all of the management, the applications, basically all of IT management is centralized, it's then virtualized and then delivered as an on-demand service to any user on any device at any time. So the processing being centralized means the endpoint device becomes of little consequence. So the end user is not operating system or device specific, so we've got device and OS independence for the end user. The other benefit, of course, by centralizing everything, all of the processing is centrally pooled, done at servers which run far more efficiently as a shared resource than individual workstations which have to be specified for each individual user's needs. So in essence, let's just touch upon the key bits. Well, all of the data is centralized where IT can control it, can centrally manage it. Included in that, and I'll bring management up as well, because this all fits in the same. IT centralizes everything, the data, the applications, all of the user management. Everything is managed as single instance management, done once at the server and then delivered to the users. So patches, fixes, upgrades, not done at individual workstations, all done centrally by IT and then delivered to those multi-users. The control of user access is, of course, centralized, so that's access to both the applications and the data, controlled at the press of a button by IT centrally. Deployment of new users can be done instantly. If you look at workstation deployment now for CAD users, we've probably got 35, 40 gig minimum of data being loaded onto a workstation. Each install, that is, for each user. Well, this takes a significant amount of time. By centralizing all of the applications and managing that centrally and the user access, we can deploy individual new users with exactly the right applications, the right versions, the right tools that they need, and that can be done instantly as an individual basis or even as a group basis. And if you look at the requirements we're seeing more and more these days for collaboration, we see different groups of users during the project lifecycle, and that's never changing users during that time. So all centrally controlled, much easier for IT to centrally manage and deliver those apps, and access to the data, but access to the right data at the right time. So for the users, of course, we have access when they want it, where they want it from, improves their productivity. As I said, all processing centralized to the endpoint device, device and operating system independent. This, of course, for remote users, branch users, site, home, fits into bring your own device policies and everything else. Now, for IT at management level, the key thing about this is the security. The data never leaves the central servers or the data center. All the users access it from remote locations. They come in, but the data never leaves. It never goes to them. All that moves across the network or out to the end users, keystrokes, mouse movements, pixel changes, that's all they're seeing. So nothing is ever transferred out. Now this for collaboration for many companies these days, there is always a compromise, which is the fact of security. Once the data is transferred off the corporate network out to third parties, obviously IT loses control over it. So with virtualization, they don't. It keeps the data under the control of IT and gets over that security issue. So what we're talking here is, by doing this, virtualization for companies brings massive financial savings, reduces total cost of ownership, improves return on investment. So, and of course, not so measurable is the huge savings in IT management. So ultimately, virtualization will improve enterprise mobility, allowing the business to respond to its changing needs and demands, scaling up and down as the project's demand, makes it more responsive, more able to meet the needs of BIM and collaboration, and underpinning all of that with levels of security that obviously the business needs and IT demands. So that's very briefly virtualization. Let's get on to the guts of today's subject, which is, of course, Citrix and Nvidia. So I'm going to talk very briefly about Citrix and XenApp for starters, because this is where we've started from with XenApp, and XenApp is a key product from Citrix. We're going to see a new version coming out shortly. A lot of people concentrate on Xen Desktop, but XenApp has been a very important product and will be a very important product as we move forward. To date, we've used XenApp to deploy CAD software. The reason for this is we are scaling at approximately 20 CAD users per physical server. Now, Xen Desktop has always had the restriction of a one-to-one relationship user to GPU. That's obviously gone in the new versions we're seeing now with 7 and 7.1. What we would do in terms of CAD deployments would set up a virtual XenApp server for each GPU. So we would use XenServer or indeed VMware as the hypervisor, as long as it's VMware 5.1 plus. And what we're doing there is we would do what's called GPU pass-through, or I think VM call it direct path. Now, by doing this, by setting a VM for each of the GPU, this would allow us to have multi-users accessing each of those GPUs and being able to share that resource. And this is obviously key in terms of scalability, because the former Xen Desktop with a one-to-one relationship didn't give us the scalability we needed for CAD users. So we've seen changes. Obviously, the changes in the developments with Nvidia Grid mean we've now got multi-GPUs on a single board. So we would set up more XenApp VMs, one for each of the Kepler GPUs on the board, obviously different K1, K2, and therefore more users per physical server. But to be honest, this does have its limits, and I'll talk about different user groups and how they draw on different GPU amounts and require different memory or different CUDA cores. I'll touch on that a little bit later. But what we were finding was the limits, the more XenApp VMs, load sharing, multi-CAD users, more efficiency with the Grid GPUs. However, the benefits of the Grid GPUs, they're that good that we were actually seeing the bottleneck being moved to the CPUs and not being able to do the processing at CPU that we needed. So obviously faster CPUs, we've seen the new Ivy bridge, the E5 2600 series, the V2s, which are improving that side. So all the time we're seeing huge developments and benefits from one side and then the other. Obviously the benefits with the GPUs from Grid, the Grid technology from Nvidia giving us more Keplers available on the board, therefore more XenApp VMs meant we could up the volumes again. However, we then get to the restriction at CPU. We're seeing now the developments in CPU, so we'll again be scaling the solutions better. But what we have seen in conjunction with that development from Nvidia and the development obviously at CPU level is of course the developments from Citrix. So what have we seen from Citrix? Well, in conjunction with Nvidia we saw the VGX hypervisor, and this basically has change things. This is embedded in the Grid cards from Nvidia. So this gives us a different option in terms of how we deploy. So in conjunction with Xen Desktop 7.1, we basically, this allows virtualization of the GPU itself, and therefore we can have multi-users sharing each GPU. The key thing is it's the virtualization of the GPU itself as opposed to us having a VM sharing a single GPU by having multi-users accessing the VM. We now can actually have VMs talking directly to the GPU. So this supports OpenGL 4.3, Microsoft DirectX 9, 10, 11, Nvidia CUDA 5, and it means we have multiple VMs accessing the same physical GPU. So with virtualization of the GPU itself, it allows those VMs to talk directly to the GPU without translation by the hypervisor and without having to revert back to the CPU for commands. So this is where we're getting around the CPU bottleneck as well, and improvements there. So let's look at this in a little more detail, and I've obviously put an Nvidia slide up here. So the Nvidia grid technology gives us the ability to offload graphics processing from the CPU to the GPU in virtualized environments. So this obviously gives us much greater processing power, and obviously frees up the CPU where we were seeing the bottleneck in our GPU in the pass-through that we were doing with the XenApp VMs. This is getting around the bottleneck we were seeing at CPU. So it's the industry's most advanced technology for sharing GPU hardware acceleration between multiple virtual desktops. Doesn't compromise the graphics experience, the application features, compatibility, all exactly the same as they would be at the desktop. And this, of course, is the VGX hypervisor that's embedded in the grid cards that makes this possible. So let's talk about VGPU. The VGPU technology, the graphics commands of each virtual machine are being passed directly to the GPU. So no translation by the hypervisor. So this allows the GPU hardware to actually be time sliced to improve the performance. Now, the grid cards, which allow the VGPU, allowing virtualization of the GPU when used with the VGX hypervisor, i.e. XenServer 6.2 and XenDesktop 7.1. So if we look at the Nvidia cards, we've got the main ones certainly that we're using, the Grid K1, which has 16 gig of memory. It's got 4 Kepler GK107s on board, 768 cores, and we would be running somewhere in the region of 32 users off that card with the virtualization profiles we've got available. With the Grid K2, we've got 8 gigs of memory available on 2 Kepler GK104s, but we've got 3,072 cores available. So we'd be looking there at much more the power users, and we'd be scaling that at 16 users per card with the VGPU profiles we've got, and I'll move on to those in a minute. So the GPU, when used in this way, the GPU can actually launch new kernels itself. It doesn't have to revert back to the CPU, so we can harness the true power of the GPU and all of those cores we've got available. It reduces the draw on the CPU, so we've overcome that bottleneck that we were experiencing at CPU previously. So let's have a quick look at these profiles, and there's a lot on this slide. I don't like putting much information on slides. I think it's better to vocalize things, but there's a lot of information here. Let me just explain to you what we're looking at. The VGPU profiles that we have available. Well, we've got the cards there, the Grid K2 and the Grid K1, and underneath you'll see the K numbers. They are the different virtualization profiles that we can set up on these cards. I've then indicated the amount of memory that allocates in that profile, the number of screens that you can use, resolution of the screens. The next column, which is the key, is the number of users and the type of users. And I think you can see here what we've got is we've very much got a mix of different profiles available, which allocate different memory depending on the user type. What we will see with different applications, if we're talking about standard 3D applications, and we'll talk specifically about 3D here, not about 2D. A lot of 2D can be done down at that sort of knowledge worker stage on the Grid K1, where we would be scaling at 32 users. That would cover 3D users also. But if we're talking about your average Revit user or something of that nature, we will be looking at the Grid K1 with the power users at 16, possibly even 32 users, depending on the files and model sizes. But for programs like Revit, it's actually quite important to have the memory available to the user, probably more so than the CUDA cores. If we're deploying something like 3ds Max, then we can take full advantage of the CUDA cores in the Grid K2, and we'd be looking at that in the power user range. Again, flexibility depending upon what model sizes, file sizes we're dealing with, and the workloads. So it's really key in these deployments to fully understand the users, to understand the workflows, the model sizes, files, the nature of the different applications that they need to touch upon. No one's using single applications these days. Everything fits in with others. So this slide's really just giving you an idea of the flexibility that's available. And I would expect in any deployment that we do, and I think in every one we have done, we're always seeing a mix of different profiles available for different users. And at times we're still deploying with XenApp, which is a better fit for some people in terms of what they're trying to achieve, be that through just a published application icon appearing on their existing desktop, be that through a full published desktop from XenApp, which we can do, or indeed mixing in with the VDI deployments that we're doing with the VGPU. So there's a whole range of what's available and how we do this. So these are the profiles for VGPU. I'm going to give you a really brief touch upon some of the technology that's behind it. This is actually, that's not a very good slide. It's not come out very well. I apologise for that. I didn't check that one. What I'm going to do really briefly is just give you a little bit of information on the technology in terms of what is this VGPU, what the VGX hypervisor, what are the things that make it work. Well, the first is something called SMX. This basically allows delivery of more processing performance and efficiency. It's a new innovative streaming multiprocessor design that basically allows a greater percentage of the space to be applied to processing cores as opposed to control logic. So this is rapidly, massively improving the performance at multiprocessor level. The second key thing to touch upon is HyperQ. This basically slashes the CPU idle time. It allows multiple CPU cores to simultaneously utilize a single Kepler GPU. So it advances programmability and the efficiency. And what we're talking about here, this is allowing 32 concurrent work queues as opposed to the single work queue that we were looking at with Nvidia's Fermi architecture, which most of the technology we were talking about before. So this is massively improving simultaneously multi-processes, increasing GPU utilization. The last thing I'm just going to mention upon is the dynamic parallelism. I always find that difficult to say. This simplifies GPU programming, allows programmers to easily accelerate all the parallel nested loops. So it results in GPU dynamically spawning new threads on its own without going back to the CPU. So this is the technology that makes this all work. So the ability for a GPU or GPU thread to launch a parallel GPU kernel dynamically, simultaneously, and completely independently, not needing to go back for translation at hypervisor level or back to CPUs for commands. So this is how the technology works, what makes it so efficient, and what gives us the benefits we're talking about. So we've touched upon the technology, on what it does, on how it works, on what it gives us in terms of deployment options. What's the impact going to be? What's the impact going to be in terms of the market for us? Well, Citrix and Nvidia have obviously secured their position as leading companies for virtualization, specifically in the design and CAD user markets with this technology. It really stands them head and shoulders above everybody else. As I said earlier, with XenApp, we can use VMware ESX 5.1 Plus for GPU pass-through or direct path, but this really takes us on a step in terms of what's available for design users in terms of deployment. We've moved basically from application virtualization with XenApp, as I said, having to publish the app through XenApp in terms of a published desktop or an application icon on an existing desktop. We're now talking about full VDI with a full virtual desktop. What I will say to that is, of course, we will see mixed deployments. That's not always the right deployment style or strategy for a company. We will see mixed deployments with application virtualization and desktop virtualization hand in hand. But the benefits and the options we're now given with full VDI available for CAD and design users is obviously immense. In terms of scalability, the different profiles we've got available, the different mixes of different profiles will suit all of the different types of workers. The compatibility we're going to see between applications, tools, plugins, all virtualized on the same desktop together is obviously going to improve significantly. But that scalability, the different users, being able to deploy with different profiles for the different user groups, meeting the needs and isolating those different users, because this is quite key in terms of where you've got real power users. You don't want in a pooled, in a shared virtual environment, you don't want a power user drawing all of the resource available from your knowledge workers, let's say, and not having your resource available for them as they need it on demand. So this very much allows the isolation of the different user groups so that we can ensure we get the right deployment to meet all of the users' needs across the board. The last thing we're going to mention, obviously, is cost savings. This is virtualization in itself in terms of cost of workstation deployment. Obviously, the benefits of virtualization, the centralized data processing, application management, user management, the mobility you're giving the workforce, meeting those needs for bring your own device policies, improve productivity from the workforce, the enterprise mobility that it gives you, upscaling, downscaling to meet the project needs. All in all, an investment centrally in a virtualized deployment is going to be a much better return on investment, reducing the total cost of ownership, and obviously giving the security that IT needs without compromising the data. So it really changes how we can deploy. It gives us greater options. It's full VDI for CAD and design users, and I think that's an important point to make. Now, finally, and we're just hitting the clock, I think. I said we had a lot to cover. I do have to rush through these things, I'm afraid. Half an hour is not really enough on some of these webinars. So what I will say is I've popped my details up there because my final point is this: it isn't enough time to get into great details on these subjects. We just give little tasters, a little bit of information for you. Our details, or my details, are there, and our website details. There's lots more information on the website. As I say, the link through to the different videos that we do on our YouTube channel. What I would say is get in touch if you wish to discuss this in more detail. We've got experts here who are happy to talk through your particular requirements or give you further information on VGPU and XenServer if you need that. The final point I'm going to make is this, that this should not be a compromised solution. We are delivering workstation comparable performance even over the WAN. So this really is very viable technology now. We do have demo servers available, set up in both EMEA and in the US. We can give you access to those demo servers. As we say, seeing is believing. It gives you a chance to upload some of your own files, your own data, have a play. Now, you would be accessing these demo servers over the open internet without the benefits of WAN optimization, but you will still be massively impressed at the level of performance we can achieve. Well, I have to leave you at that point. My clock has hit the mark. I'm going to thank everybody for listening and your time today. I hope you found this of interest. What I can say is, obviously, today's session is recorded, and we'll pass that recording out to everybody for you to share. Otherwise, go on the website, have a look at what we've got. But I hope everyone has a good day. Thank you very much for your time today. Thank you, and goodbye.